In this example, we're asked to find the domain of a function that will contain some domain restrictions. We know this because we see a square root within the function, and we also see this denominator with an expression that contains the independent variable as well. So let's first focus on the part of the function that contains the square root. And specifically, we're going to pull out just the radicand. That's what's underneath that radical. And we want to make sure that this expression here is greater than or equal to 0, because we cannot take an even root of a negative number and have an answer that is a real number. So we solve this little inequality here, and we get the following, that t has to be greater than or equal to 3. So we know that's going to be part of our domain restrictions. The next piece we're going to focus on is the denominator. So what we want to do here is state that the denominator cannot equal 0 because we do not want to end up dividing by 0. So we solve this little equation here, and we end up saying that our variable t cannot equal 6. So these two pieces of information tell us where the domain is restricted to. However, we're asked to write our answer in interval notation. So if you're still a little unfamiliar with interval notation, what I would first do is suggest let's graph where the domain does exist on a number line. So I've set up this small number line here. I'm going to go ahead and start with where t does not equal 6 and put an open circle there. And then this next one where it says t is greater than or equal to 3, because it's greater than or equal, I'll put a closed circle on the 3, and I'm shading to the right, remembering that I'm not going to shade at the 6 because t cannot equal 6. So what you see here shaded is where the domain is for this function. And actually this is two separate intervals. So that's why you see two separate pieces in our solution here. This first interval contains the endpoint 3, but does not contain the endpoint 6. So when we want to contain an endpoint, we use a square bracket. When we do not want to contain an endpoint, we use a parentheses. We always list these values inside the interval from left to right or least to greatest. So that's why we see here square bracket 3, comma, 6, and then parentheses. Now the next thing you see is this U shape. You will find that symbol for union, is what that's for, in the math palette. So I've just taken a screenshot here of our MyMathLab like assignment page, but you'll see that towards the bottom of your screen. Then to write the next interval, we'll start this one at 6. So I don't want to include the 6, so I've got now another open parentheses around the 6, and it continues on into the positive direction forever, which symbolically we're going to put that as positive infinity. I never contain that endpoint of positive or negative infinity, so that will automatically get an open parentheses. Again, least to greatest or left to right, we'll have here open parentheses, 6, comma, infinity, and then another parentheses.